Hi again, everyone. Cyber-physical seafood systems, intelligent and optimized green manufacturing for marine co-products. It seemed like a good idea at the time when we put the bid in, when we were trying to capture everything that this program is about in a single sentence. Subsequently, we call it cyber marine, and you can probably tell why. This presentation will introduce you to anyone who's new to the program and remind the rest of you about who's involved, what we're doing, and why we're doing it. Cybermarine is a Ministry for Business Innovation and Employment Endeavour program, and it fits within the advanced manufacturing space. It's for 5 years and it finishes in October 2025. It's a pretty large program at $16.3 million. What we're after in the end is to create a factory of the future that will process non-meat marine products. It needs to be efficient, low energy, non-polluting, and making the most of every single kilogram of raw material that's captured in New Zealand. It's about doing something that's different to what we're doing now, and hopefully will go across the whole industry. We have an absolutely fantastic team working on this project, and it is truly collaborative. We're trying to work together very, very closely. We have the team here at Plant and Food, team at Callaghan Innovation, the Computer Science Department from Victoria University of Wellington, the chemists from Otago, the biotech people from Deakin University in Australia. We're building a collaboration with Nefima in Norway because they do quite similar work to us, and bringing in industry partners right across New Zealand. The Deakin University is doing some work in some of the research aims, but Colin Barrow, who is the chair of the biotech department, is also heavily involved in marine products R&D in Australia, and he's going to talk about this later in the program. The program is also about developing the people who are going to work in this factory of the future. Because what we realized when we were trying to build PhDs into this program, particularly amongst Maori, that it's really hard to get kids into science in the first place. So we put a huge amount of effort into trying to explain this program to kids, get them engaged, and they're coming along, and Hemi is going to talk about that later. We have postdocs. Ellie Rudebeck from Deakin is going to talk a bit about some of her work later, and David Aitchison from Trinda Engineering about the summer student that we got from the engineering department at the University of Canterbury. I suppose what it comes down to is, why are we doing this? And I think in the end, we all realise that we need to get better returns from our marine biomass. New Zealand's a sort of special case because although we have a very large area that we fish, we don't actually have particularly high numbers of fish. We don't have high numbers of single species, which makes a difference too. There's about 600,000 tonnes of wild capture that's potentially available, but we only catch about 400,000 tonnes of it because some of it is not considered valuable enough to cover the cost of harvest. We're looking at static or reducing quota, which means to support the industry, we have to get more from what we've already got. And in amongst all this, we've got increasing aquaculture. And so I've asked, and in the marine product space, this is going to become increasingly important as the more aquaculture we have, the more aquaculture byproducts we're going to have, and perhaps even aquaculture species that are grown particularly for making marine products. So as part of this, I've asked Susie Black, who is the program leader for Reimagining Aquaculture, another large ENVI program about open ocean aquaculture, to talk about what she's doing and what her team are doing to give some context around how the Cybermarine program fits amongst other research programs. In the past, New Zealand has had a habit of focusing on single products, and this is what we're trying to change. So I'm not suggesting that there's lots of waste, which everyone knows is something that I get on my hobby horse about. There's no waste, things go through to rendering plants, but we do have a tendency to see a fish as fillets and other stuff. And what we're trying to do is change how you look at this organism so that you're looking at a whole range of products rather than just the one focused and then, oh, I've got to do something with the rest of it. Up until now, we've had very limited co-products processing infrastructure, which has really limited what New Zealand has been able to do. But we're really starting to see a change now. Andrew Stanley is going to talk about some of the work that Sanford is doing to move them more into a more holistic view of the raw material. So we're really looking forward to that. But when it comes down to it, there are very, very few marine products in New Zealand, and even fewer that are actually new and novel. So even the things that are going on now, there's a lot of doing things that we've been doing for a very long time. It's one of the very few new things is active layer. And so Ian Hosey is going to talk later in the program about how they managed to take Hoki collagen and turn it into a completely new product with huge potential for revenue to New Zealand. And so the second reason that we need cybermarine is that we need an ability to adapt rapidly to change. It was one of the things when we were developing the program, as you know, you're always asking, so why aren't we doing this now? What's different about New Zealand? Why aren't we making more of our marine byproducts? And so you come down to things, one of the biggest questions that we have, how to overcome our problems or perhaps opportunities with diversity and variability. Unlike some of the big European countries, we don't have huge volumes of single species. We've got more than 100 commercial species. We see massive seasonal variation. Not everything is filleted, and that sounds sort of like, oh yeah, so what? But that actually makes a massive difference in the marine byproduct space, because it means it's not economic to pull the organs out. So we had to start at a different space about how are we going to overcome this. Some things that are filleted, we don't always get the same raw material. Sometimes there's roe in there, sometimes there's not. More and more the skin is being taken out to make collagen, but it may be in there sometimes. Sometimes the heads are removed because people are eating them or because they're going to crayfish bait. We need to be able to deal with all of this. We've got bycatch. Sometimes we've got mixtures. And then as we're going forward, we're also starting to see effects of climate change on what is actually being caught. And then we will be getting new species coming through as for aquaculture. So I just need to turn my notes over to make sure I don't forget anything. Also, we considered in this, it's all very well for scientists. We get very excited about making new products, but in the end, this project has to transfer into something that you guys can use. And so it's no good us working out processes that make all sorts of wonderful things if nobody wants them. So part of our program as well is how to bring in the market trends. How do we how do we use that as a weighting factor to decide what's the best product mix to make. And in amongst all this as well, change, we need to reduce our reliance on coal and diesel. A lot of these processes are very energy inefficient. And so we're looking at how we can do it to use much less energy and be much more efficient. So in the end, this is actually a picture of a dairy factory, but I like it because it's so shiny. We want to make something that looks like this. We want to have clean, modern, computer-controlled, high quality products and very, very controlled. So there's some really big science questions that go behind Cybermarine, because in the end, Cybermarine is a research program. And sometimes they sound particularly, we look at this and we go, yeah, that's what's so difficult about that. But I've already told you about the diversity, and that actually is a key problem that we need to overcome, not just in New Zealand, but globally, around if you stick the fish in the blender, or you've got a mixture, or the tissues are different, how do you know what's in there? And until you know exactly what's in there, you can't work out what to do with it. So we are focusing on spectroscopy as a means to really quickly understand what is in our raw material, and then to be able to decide what to do with it. But using spectroscopy generates vast amounts of information. And I know here, Dan does some spectroscopy and he analyzes the data, and a day or two later, he can tell me what's in there, but that's not going to work when you're running a factory. So that's what the computer science guys at Vic are doing. They're trying to work out how we pull all this together to be able to tell you instantaneously what's in your mixture. Next, how do we get all the components out? A lot of the processing technology is already there, but it's all focused on single products. I get the green shell mussel oil out, and then we're left with mark. We don't want to be doing that. We want to be able to get everything out in the right order. How do we get it out so that we can use everything? How can we be efficient? Energy, how can we keep it safe for workers? And then finally, once we've pulled all these things out, what can we do with them to make something that is totally unique, that will set your business apart, will set New Zealand apart with new products that actually do something and have a market? So this was my attempt to put the whole program onto one slide. I'm just going to move this over to the side because I can't read my own slide. Oops, let's go back. So Cybermarine, we obviously can't work on all of the species that are available in New Zealand to start with, because it would have been impossible. So we chose 3 exemplar species. Green shell mussel, which is obviously a high value nutraceutical stream now. Hoki, which is one of our largest species, and mackerel, because it's highly underutilized and yet has very, very good nutritional properties and interesting molecules in it. So Hoki is our example of a white fish, mussels as our exemplar shellfish, and mackerel as an oily fish. And if you look at the flow here, as I said in the previous one, our key thing is around analysis. And this is the focus of section 1 in the talks which are going to follow. So it's about real-time detection of molecules and responding to the composition. But there's also a lot of work in there around how do you actually know that your analysis is good? How do we actually know what is in there? And once we can do this and it's tied together with the computer science, it's offering in the future a path to creating automated factories. The next step is the integrated green processing. So part of this is pulling out equipment that you guys already have in your factories and processes that you're already running, but then working out how to put them together to use that equipment, and then understanding what you're missing. What are the key questions that we need to address that will allow us to create a multi-product cascade? We want to be able to start at the beginning, pull every single thing out intact without the process damaging the next thing down the line. This sounds simple, but actually it's not simple at all and is occupying a great deal of thought. We go down to unique new products, but Cybermarine's not just about new products. It's about putting existing products into these cascades. It's about how do we purify things? How do we modify things to change their properties so that you get something new? And then finally, it's about testing the concept. And so Owen Catchpole from Callaghan will be running this final part of the program in a year or two. We'll be building pilot scale facilities at Plant and Food in Callaghan, and then making sure that it works when we put all of the unit operations together and the analysis to make sure it works. And then the ultimate test is doing it with something which is not an exemplar species to see if it works. And I just thought I would put this slide in because this one always resonates with people. It sort of explains why we're doing what we're doing. The slide came out of the original program. You might disagree with some of the numbers down the side, but it just gives you the general idea. So mackerel, current practice, if we caught it all, it's worth about $1.95 a kilogram green weight. If you decided to render the whole fish and not even bother trying to sell it whole, it would be worth 60 cents a kilogram green weight. If you put mackerel into our proposed Cybermarine factory, only through to the first part of it, relatively simple products without all of the modifications that we're proposing to make new products, it comes out at around $8.50 a kilo. So I think there's huge incentive for us to make this work. And so finally, I found this slide when I was looking for pictures for this presentation. And it was there, it was from a presentation a really long time ago. You can tell from my haircut and the youthful look of Ivan. But really, this is still what we're trying to do. But I like it because I feel like we're a lot closer to actually being able to do it now. There's huge optimism around the program. It's the right time for the industry. It's the right the processing industry. It's the right time for the fishing industry. There are environmental pressures, and we have the right team. So thank you for listening. I'm sure you're going to enjoy the rest of the day. We have a really great lineup of speakers, hopefully inspiring you and sparking some vigorous debate about the future of the marine products industry in New Zealand.